Okay, so welcome to all the student in this lecture, that is information theory and coding. So in this lecture, I will discuss about the various coding style like Huffman coding or Shannon coding. I will take one example of the based on the Huffman coding. Then I will discuss how to write the code of all different kinds of symbol. Okay, so actually why this coding is important. So nowadays if you see in the communication system, mostly there is a type of there is a one transmitter and there is a receiver. Okay, so this source generates a various kinds of message like m1, m2 and m3 and m4. Okay, so here actually all these message are to be transmitted to the receiver. Okay, so definitely all these message will be received by the receiver. Okay, whatever we send at the transmitter source. So before sending this message, we have to encode our message. We have to encode our message. Okay, and then in the receiver side, we have to decode our message. Okay, then you get all these message. Okay, so the transmitter side, the encoding process, and in the receiver side, we have to apply the decoding process. Okay, so now here, that's why this encoding how to encode our message. So there is a various kinds of technique like one technique is like Huffman coding. Okay, Huffman coding. Okay, another is Shannon coding. Okay, Shannon coding. Okay, so in both the technique, there is some different approach to encode all the message. Okay, so in this lecture, I will more focus on the Huffman coding style. So I have given a one very beautiful example here. So I've taken a five symbol x1, x2, x3, and x5. Okay, so the first step, you have to write all these message x1, x2, x3, x4, and x5. Okay, and after that you have to write all these message. What is the probability? Okay, okay. So this probability is already given in this question. So we just copy and paste all this probability. Okay, and this is 0.15 and this x5 probability is 0.1. Okay, so this is the first step. Okay, so after that we are using the Huffman code. Huffman code. So here actually the next step is that these two messages are to be combined. Okay, so these two messages are to be combined. So after combination, I think you get a 0.25. Okay, so ultimately, however, all the message means whatever you write the message, that is you have to arrange in the descending order. Okay, so this is my highest probability message, and again this 0.25 come here. Okay, and then the next lowest probability is 0.9 and this 0.6 is less. Okay, so that's why I written in the bottom side. So again these two messages are to be combined. So after combination you get 0.35. So 0.35 is less as compared to 0.4. Yes, it is. So you write in the second position. Okay, you write in the second position. So this is 0.35 and this message you have to copy here, this probability. And again, these two messages are to be combined here. So I think this is a 0.60 value. Okay, so that is very highest value. Okay, so we write this on the top side. Okay, and this is the lowest probability. So we write in the bottom. Okay, so fine. After do all these arrangement of the message, then you have to start the coding process. So first these two messages you are combined, then you write top side 0 and the bottom side 1. Similarly here 0 1 and similarly here 0 1 and similarly these two messages also combined, so that is 0 and 1. Okay, so fine. Now we have to execute to draw all the codes. Okay, we have to execute and draw uh, all the codes. So fine. So I return here 0.4. This is my first message, and this is my second message, and this is my third message. Okay, and this is my one message. Okay, so this 0.4 is going here, this is going here, but there is no code here, and this is and also there is no code here, and again 0.4 is going here, but here you have written 1, so that means the 0.4 and the code is 1 only. Okay, now we concentrate on 0.919. Okay, so this 0.9 is going here, and what is the value here? 0. Okay, this value is 0, so we write 0 here. And after this combination, this value is going here, and this is 0. Okay, so we write 0 here. And again, this message is combined here. And after combination, you assigned here 0. Okay, so this come here 0. So this is the code for 0.9. So here you get 30. Okay, you get 30. Now we concentrate on my third message. Okay, so this is my x2, this is my x3, and this is my x3. So what is my x3? 0.16. Okay, so we see here 0.16 is going here, and this message probability is 1. Okay, so we write 1 here. And again, this is combined here. After combination, this is 0. So I written 0 here. Okay, again, this message is combined here, and this is going here. And again, this code is written 0. Okay, so this 0.16 message, this 0.16 probability message is 001. Okay, now we come to our message 0.15. Okay, so I will take some other color, then you are more, then your concept will be more clear. Okay, so okay, so 0.15. Okay, so this is 0, so I write 0 here. Okay, so 0.15 message is combined here and going here, but there is no code here. And again, this message is going here, and here you return 1, so you write 1 here. Okay, again 0.25 is combined with 0.35, and this is going here, and you have assigned here 0. Okay, so this message code is 010. Okay, so now we come to our last message, that is 0.1. Okay, so I will take some other color, then your concept is very clear. Concept will be very clear. Okay, so this 0.1. Okay, so here you written 1. Okay, so I written 1 here. Again, this message is combined here and going here, but there is no message here. And again, this is combined here, and you written 1 here. Okay, so this message is 1 here. Okay, so again, this is combined here, and this is 0, so this is 0. Okay, so this code, this message code is 011. Okay, so ultimately you get all this code. Okay, ultimately you get all this code. So after that, you have to calculate the length of this message. Okay, so that just you count the number of bits. So here number of bits is 1, here number of bit is 3, here number of bit is also 3, here also 3, and here also 3. So ultimately, they are asking the code length in this question, and they are asking the efficiency. So ultimately, the code length is the formula, that is sigma pi into ni. Okay, so how many messages are there? I think it is 5 messages. So I value is going from 1 to 5. Okay, so that formula you just use, and you have to calculate the code length. Okay, so that is your code length. Okay, I'll represent the code length. Now we have to concentrate on the efficiency. So efficiency formula, if we see, the efficiency formula is Hx divided by capital N, and Hx represent the entropy. Okay, Hx represent the entropy. So we know very well the Hx value, Hx formula is pi into log 1 upon pi. Okay, so I value is vary from 1 to 5, because here there is a 5 kinds of message: x1, x2, x3, x4, and then x5. Okay, so just you put all these value, and you have to calculate the h value and just put here, and this l value you put here, and you get the efficiency. Okay, so this is all about the Huffman coding. So I am try to given the concept about the Huffman coding, how to encode all this message and how to get all this code and how to calculate the code length, and after that how to calculate the efficiency. Okay, so thank you to all the students for carefully listening this video.